All right, and so just knowing our formulas, we can do a lot of different things now. So we know if we, let's do this way, the derivative, we know the derivative of sine is cosine, and the derivative of cosine is sine. Okay, so now if we're given one like a function like this here, so the derivative of f of x would just be, and this is the product rule, right? We have two functions. We have our f function here, and then we have our g function here, right? Okay, so let me just label those again, but without the circles, just so we can see them better. And so, so the product rule, f prime g. So I'm going to do the derivative of f prime would be 15x squared, right? And then g prime, the derivative of sine is cosine, right? So it's just going to be f prime g, so it'll be 15x squared sine x, so g stays the same, plus g prime cosine of x times the derivative, or times the regular f, so it'd be 5x cubed, right? And normally you put this in the front, but just to kind of show you the fg prime, so I'm just gonna, you can do that in your head. You don't have to like show both of these steps here. You can go straight to the answer on this one, but this is how it should look, or this is how it'll traditionally look. If you left it like this, that would be full credit, okay? But yeah, this is how you'll see it most of the time expressed. All right, so pretty straightforward. So just remembering that derivative of sine is cosine, derivative of cosine is sine, and then we can use it now with all of our other rules. All right, so let's try this one out together. So here we have another product rule situation. So we have two functions multiplied together, and so we have an f function and a g function. So let's start by finding the derivative of f. So what's the derivative of sine? Good, cosine. And what's the derivative of cosine? Nice, negative sine. All right, and so now we have everything we need to use our formula. So f prime of x, f prime g, so that'll be cosine times cosine, actually, right? So f prime is cosine and g is cosine, plus g prime f. So that's going to be negative sine, right, times positive sine, right? Okay, so here's f prime g, and then we have g prime and f. Okay, so what happens when we multiply cosine times cosine is we get cosine squared, right? That's how we write cosine squared. And then here, if we multiply negative sine times sine, we get negative sine squared. All right, so that's the derivative of this function here. Now we could do some trig identities here, like, or we could utilize some trig identities. For example, this is actually the double angle formula. Like, if you guys remember back to trig, let's see, where is it? There it is. So cosine of 2 theta equals cosine squared minus sine squared. And so we can actually, if we wanted to, we can actually say this is cosine of 2 theta, because this right here equals this, right? Like cosine squared minus sine squared equals cosine 2 theta. So anyway, this is okay, just leave it like this. But there may be times where I might, ask you to use a trig identity to get down to a single trig function or something like that. Otherwise, you don't have to check every time and see, if it's equal to 1. But this is just one application of trig identities that you learned back in trigonometry. You might be wondering why you did those. And yeah, then calculus is a big reason why we do trig identities. And you'll see a lot of the proofs that we use or that we do to find the derivatives of trig functions are based on trig identities.